Hey, real quick, look at the first graph. Don't look at the directions. Tell me what you think the answer is. System of equations. It's that simple. You see two lines, you're trying to tell me where they cross. So for that first graph, even though you're not looking at the equations in question, you are looking at the graphs for them. And we could just say, hey, this dot where they cross is at 1, comma, -1. And that's it. So it's not going to be this easy all the time. Obviously, you're going to have to do some graphs yourself. Anyhow, not sure what that was about, but let's keep going here. So on the second graph, again, all we're looking for is two lines cross. Hey, just quick memory check here. Remember what a function is called that is a horizontal line? It's called constant. And all these guys are called linear. So we just got to count. So I got an x coordinate of -3, comma. I got a y coordinate of +2. That's where they cross. That's the solution to the system. Okay, these next two are a little bit funky. I'd like to think you could tell on this graph on the left, they do not cross. So common sense answer would be, in math, when you can't figure something out, you write this symbol, no solution. So then cross, they're parallel lines. They have the same slopes. Now this last one could be a little confusing. If we're saying a system of equations, that means there's two graphs there. So you might say to yourself, well, I'm only looking at one. Where's the other one? Well, it's got to be there. So let you think about that while I change colors. Well, imagine that was the first line, and then coincidentally, the second line ended up right on top. So they intersect in multiple spots. Now, we'll hold you to this. I'd like to see you give me the correct answer here. It'd be really tempting to say something like all real numbers or all numbers, because that's sort of a possibility for an answer to an equation. But this is a system of equations. So what we're going to say is, if you said all real numbers, that means you're telling me any number. And that's a set of coordinates right there. That's any number. And that's obviously not on that line. This guy is obviously not on that line. So when we say, I'm going to write it down underneath the graph, infinitely many, you are implying that, yeah, there's an infinite number of solutions, but they're on that line. So infinitely many solutions. And there really is no symbol for that, unfortunately. Okay, so I mean, all real numbers, yeah, that kind of gets you the right concept, the right idea. But I hope it makes sense to you. If you say all real numbers, you're talking about anything. That guy, anywhere. But we're talking about the guys on the line. So infinitely many solutions is what we're looking for on that guy. All right, well, obviously you're not going to have the graphs given to you all the time. Sometimes you're going to have to do them yourselves. So that's what these next two examples are. So that first equation, if we're going to do slope-intercept form, if we're going to graph something, we want y by itself. So I'm going to do this guy over here. Well, how do you get y by itself? The x has to be on the other side. If the x was positive on the left, he's going to be negative on the right. So I got a y-intercept of 3 for this guy. I get a slope of -1/1. So that guy's going to end up tilting left when I'm done with him. Down 1/1. Now, hey, two dots would do, right? And certainly we can draw a line with two dots. But if the goal is to see where these guys cross, then it might not be a terrible idea for me to get more dots. Because the more dots I have, the more accurate the line's going to be. Now, again, this stupid thing that I'm using, I don't know why you choose the line function and it doesn't draw arrows in the end, but that's something you should know, that you should put arrows. But I'm going to leave them off in the interest of time. Second equation. Again, got to have y by itself. How do I get that -2x to the other side? I got to add them, which means the sign would change. So let's see. Once again, I've done a terrible job with my graph, because if the y-intercept is -6, can you guys tell me what's wrong with that? Doesn't fit. So we're going to fudge it. 1, 2, 3, 4, 5, 6 down would be right about there. Now I'm still going to be able to be accurate, and here's why. I know my slope is 2/1, so I have to go up 2 and over 1 no matter what. Up 2 and over 1, up 2 and over 1. And so we already know where they cross, but let's make it official. Let's go ahead and get a line there. And there we go. Okay, so where do these guys cross? They cross at 3, 0. I'll just write it down here for no particular reason. 3, 0 is the solution to the system. All right, problem 2. So let's see, we got a 2x plus 5. I'm sorry, 2x plus y equals 5. Slope-intercept form, got to get that 2x to the other side. I'm going to subtract them over, which means my y-intercept of 5 I'm going to graph first. Clear up here. Now again, hey, this is easy to check. If I have a negative slope, I know I'm going to tilt to the right, tilt to the left, when I'm done with that. So if you had gone down 2 and over 1 and put him here, well, if I connect those dots, that thing's going to tilt to the right, so that can't be. So if I go down 2 and over 1 here, then I got myself a left tilting line. And that's what we're looking for. So we'll draw. Again, leaving the arrows off, but you guys please put the arrows on to make it official. So let's get this other one. It says x minus y equals 1. So if you're good at graphing the y equals mx plus b stuff, this is twice as much work, but man, it's going to be pretty easy. So let's see. I'm going to move the x over, which means he'd be negative. But I don't want negative y, I want y. I want y by itself. So a little trick, right? If we switch the sign of the y, as long as I switch that sign, perfectly legal. So this guy has a y-intercept of -1, a slope of 1 over 1. And again, that's positive, so it's going to tilt to the right when I'm done with them. A couple extra dots just to be extra efficient with this guy. And here we go. So where does he cross? He crosses at 2, 1. So I'm going to write him down here. And 2, 1 is my answer. So how would you check these if you wanted to? I mean, some of you like to be extra efficient. You could check it. Well, if we're saying that the x answer is 2 and the y answer is 1, you could plug them back into both equations and they should come out true. And in this case, I'm going to let you take my word for it when I say that it does. All right, moving along. Number 3. So again, got to have y by itself. So I'm going to just go ahead and do a step right here. And I'm going to say, well, I want that 15x to the other side. 0 isn't going to change anything. So I got them. So pull this trick whenever you want. I can change signs as long as I change signs on both sides. Get rid of the 6. All right, now 15 over 6. We're supposed to reduce fractions all the time. Yeah. So what number goes into both? 3 does. 3 goes into 15 5 times. 3 goes into 6 2 times. And understood to be a 0 on the end. You wouldn't have to write them if you don't want. So here's my y-intercept of 0. I'm going up 5. I'm going right 2 because I want this guy to tilt to the right when I'm done with him. Got him. Okay, other one. Well, let's see. I'm going to write this guy up here on the right. I've got the 5x, which I'm going to move to the other side. So he's negative if I move him. Divide by -2. So -5 divided by -2, and the 10 divided by -2 would be -5. 2 minuses, right, makes a plus. So hope you can read that. That's 5 over 2. So what's coincidental about those two graphs? They both have the same slope. But if I'm going to graph them like the direction says, then I should graph them. So there's my y-intercept to -5. There's my up 5 and over 2. So where do they cross, guys? They don't cross. And if they don't cross, we write no solution. All right, I am not going to have enough time to finish the next graph. And to be honest with you, I'm not even sure if there's any more after number 4. But if you need to see some more graphs, see some more notes, pick it up on part 2 video. Thanks for watching part 1.